All right, so this part we get into the actual arcs of a circle. First, let's talk about what an arc is. An arc is just part of a circle. Part of the outside, well, it's part of a circle. What is a semicircle? Half. Okay, so you do need to know what a semicircle is. Then we also have a minor arc. A minor arc would be considered smaller than half, because semicircle is exactly half. Which, using common sense, if a minor arc is smaller than half, then what do you suppose a major arc is? Bigger than half, right? All right, adding to that, well, we're going to do a picture. Okay, in this picture, RT would be considered a minor arc. Okay, the way that we note that you know from other notation that RT could be a lot of things. So we need some sort of visual notation. You're going to put an arc over the two letters. Okay? So if you're naming a minor arc, it's a little arch over the two letters. There is another minor arc, could be RS. Order does not matter with these, so TR or RT represents the same arc, just like RS or SR. Okay. Semicircle. Would be TS, or you could use three letters, TRS. Okay. Because it goes either way. And major arc. Okay, make a note by your major arc. Must use three letters to name it, because if I'm talking about the arc that goes from R all the way to S, and I only use RS, you're going to think I'm talking about RS, right? So we have to use a letter in between to designate that direction. Okay, so if I go around from here to here, a major arc could be RTS or STR. Okay. Part of your work in the homework is going to be identifying all the minor arcs, the semicircles, and the major arcs, okay, from a diagram. So using proper notation and proper naming requirements. Okay. if you're identifying a semicircle and you have the ability to throw in that third letter, that's better, because the problem with TS, for instance, is it could be TS this way or TS that way. So if you really are trying to be specific with which semicircle, then you'd want a third letter to indicate that. Okay. Okay, there's two more small things we need to talk about. Another vocab piece. Adjacent arcs. Two arcs with one point in common. Okay, for instance, AB and BC would be considered adjacent. And a little throwback to some things probably make you shudder a little bit because it goes back to first semester. We have an addition postulate. But the good news is you're not throwing it in a proof, so you just need to know what it means. Okay, what do you guys think the addition postulate for arcs would mean? Remember, for segments it was AB plus BC equals AC. If you add two smaller segments, you get the big segment, right? What do you think that means for arcs? Yeah. They're just adding two arcs, you get a bigger arc, right? Notation changes, arc AB. Now, we are going to throw in that little m. What does that mean? The measure of AB, okay, plus the measure of BC equals the measure of AC. Basically saying if we add this plus this, we get all of that. Okay, and the last piece. Finding arc measures. The measure of an arc is the same as the measure of its central angle. Okay. That makes it pretty handy. All right, so if this is the information that we have, we should be able to find the measure of any other central angle or any other arc with this, with what they've given us. Okay, so the first thing we're going to look at is the measure of BC. Okay, so you're going to find BC and go, okay, here's BC. If the arc measure is the same as the central angle, then what would the arc measure be? 32. Okay. then let's look at the measure of BD. If BC is 32, then how do we find BD? Add 32 to 58, okay? So it'd be 32 plus 58 or 90. Okay, so arc BD should be 90. How about the measure of ABC? Can you find that? You do have to notice one piece of information first, and that is CA. Is CA a straight line through the center? So that makes ABC what? Semicircle, which means it's 180, right? Okay. So ABC is a semicircle because AC is a diameter, so ABC is 180. And the last one we're going to do is the measure of AB. Okay, what do you have to use to find the measure of AB? Kind of the segment addition or the arc addition postulate, but so we would say, and you could say CB plus BA is CBA, but basically we know that CBA was 180, right? And BC is 32. So what do you have to do to find the remaining part? Subtract 32 from 180. So that's 180 minus 32, which is 148, right? Okay. So the biggest part of the first half of this section is identifying the arcs, naming them, finding their measures, okay? And then using what you know about the circles to find out what degrees you should have in a pie chart type situation. Okay, so that's all we're going to talk about today. Your assignment is on the board.